Welcome everyone to this session for HL7 FHIR Dev Days. Today's session is on leveraging Provenance to maintain traceability while achieving semantic interoperability with FHIR. The recording will first be presented by Sam Schifman, software architect with Diameter, and there will be time for questions and answers afterwards. Take it away.
Hi, my name is Sam Schifman. I'm the Chief Architect at Diameter Health. Today, I'm going to be talking to you about semantic interoperability, and particularly about how we can maintain traceability as we move to FHIR. First, I'll talk a bit about what is semantic interoperability, so that we can understand why traceability is important. Then, I'll talk about how we first looked at extensions as a solution, but ultimately we found Provenance was a more elegant way to solve the problem. After that, I'd be happy to take your questions. So what is semantic interoperability? Well, this is a shorthand way that I like to think about it. Structured is where in the data will I find something, while semantics is what I should find there. Now, it's slightly more nuanced than that. Structure can tell us, for example, that results are supposed to be coded in LOINC. Semantics provides the understanding that HbA1c should always be represented by this one LOINC code. This allows downstream systems not just to be able to parse the data, but to make reasonable assumptions and understand the data. This is certainly critical for analytics, but even for more prosaic things like doctors viewing the data, it requires a lot less mental work if they can rely on HbA1c's always being coded and displayed consistently. HIMSS has a great way of looking at this with their different levels of interoperability. Structure defines the format, syntax, and organization of the data, while semantics provides the common understanding of the data. So if we take a very simplistic look at the history of HL7 standards, we start with HL7v2, which is a point-to-point protocol designed to work well in low-bandwidth communication. Because of its point-to-point nature, it is not well structured. Anyone who's ever worked with HL7v2 knows that each message source does things just a little bit differently. Next comes the CCDA standard. This is a highly structured document that contains a lot of information. The issue here is that to get to the data you need to parse through a lot of data you don't. FHIR takes us to the next step by giving us smaller messages that are highly structured. It also brings some great things like a standard API, improved standardization of coding, and one of my favorites, the built-in ability to extend the model. However, FHIR does not fully address the semantic problem. First, most data is not in FHIR yet. When it is converted, most of the time people work hard to get the structure correct, but nothing is done about the semantics. But even pure FHIR doesn't fully provide semantic consistency, partially because many of the value sets used in FHIR are extensible, but also because with all the work that's gone into defining FHIR, there are still some places open for interpretation. And if there's one thing we've learned about clinical data, it is that if there are n people interpreting a spec, you will end up with n+1 results. But perhaps you're thinking that semantics isn't really a problem. This slide shows real-world data that we have seen in the wild. For example, this is just some of the ways that HbA1c has been specified in real data that we've processed. Just in case you thought that HbA1c was an anomaly, here's some of the research done by our founder, John D. Moore. As you can see, clinical data is very messy. In fact, John founded Diameter Health to solve this very problem. So what does Diameter Health do to solve it? Well, we take in multi-source data and put it through a process that normalizes the data by, among other things, identifying correct code system codes and display names. But notice we do all our normalization to national standards. Diameter Health maintains no internal code systems, enriches it by filling in things like medication ingredients and classification. We'll actually look more closely at this example in a moment. Reorganize it by recognizing things like immunizations that come in as procedures and treating them as immunizations. Reduce duplication by applying in-depth clinical expertise to identify duplicate data and combine them into one entry or resource. We are also able to bring multiple documents into a single summarized document for that patient. Currently, this is only available as a CCD because FHIR does not yet have a standard for packaging all the resources for a patient into one response, although we wouldn't be surprised if we see one emerging soon. And finally, we convert legacy data to FHIR through a complex clinical mapping and a process that resolves references to maintain referential integrity. Here is just one example of an inbound CCD where the XML is missing the code and code system for a systolic blood pressure. Diameter Health correctly identifies that this should be in LOINC and puts the correct code and code system in the resulting FHIR resource. Just quickly, here is another example where the CCD came in with no units for a BMI. Diameter Health knows what the standard units are for BMI, and so it fills it in the resulting FHIR resource. Medications are a great example of where we do enrichment. Here is that example from above, where the medication came in as Vicodin, and Diameter Health is able to show that it is really a combination of acetaminophen and hydrocodone, complete with tall-man lettering. But even more, it is able to dissect the original instructions for the medication and rebuild them so that they are easier to read. While a medical professional can likely interpret the SIG on the left, rebuilding it cuts down on mental load, a key contributor to burnout. So Diameter Health can take in multi-source data from many different systems, apply our process, and automatically outbound clean, semantically consistent data that can be used by downstream systems to do many things. But of course, this sort of thing gives auditors heart attacks. What? You say you change the data? You can't do that. Well, there are two things that we do to make sure our customers don't need to bring defibrillators to their audits. First, everything Diameter Health does is 100% deterministic. There is no magic. We don't use neural nets or anything like that. We can clearly document how we got from point A to point B. Second, we have always been committed to provide a way for users to review the original code or value. This traceability is critical, and so, as we moved into the world of FHIR, it was important that we provide the same ability to review the original data. However, as we moved to FHIR, we wanted to achieve a few things. One was to provide consistent access to the original data. By this we mean the ability for an automated system to retrieve that data easily. We also wanted to avoid complications in the data model, i.e. be FHIR first and not introduce bloat. In the spirit of FHIR, we didn't want people who didn't want this data to pay a price for its presence. Finally, we needed to mitigate the cost of storing all that data. As you can imagine, essentially having 2 copies of everything doubles the cost of storing it all. Our first approach was to try using FHIR extensions. I think I mentioned that one of the things I think is great about FHIR is that it is extendable. Extensions allow you to add data to almost any element in FHIR. They are also normative in the specs, so there should be no problem using them in the wild. And extensions can contain extensions, so you can model just about any tree structure, which really means pretty much any data with them. Here is an example of how we might use extensions to provide the original values in the first example we looked at earlier. We show the code with the normalized data to provide an extension that shows the original data only had a display name. Some of our problems start to come in when we look at just how many places we might need to put these extensions. These are all the elements that could be normalized or enriched, including top-level fields like status. And this is just the observation resource. So do extensions meet the criteria we listed? Do they provide consistent access? I would say partially. While they certainly provide the data, they will pop up all over the place, making it hard to automate. Prevent complications and bloat? No, they add complication because the receiving system now needs to know about these extensions. And they certainly add bloat, as someone calling for the resource gets them whether they want them or not. Unless, of course, we further complicate the system by extending the API to allow filtering of them. Finally, do they mitigate cost? Well, no, for the same reason as above. Because these extensions are inside the data, we must store them with the data and cannot offload them to additional storage in any way. So we wanted to take a more FHIR-first approach, and we started looking around and found an answer using provenance. But first, what is provenance? Provenance of a resource is a record that describes entities and processes involved in producing and delivering or otherwise influencing the resource. Provenance provides critical foundation for assessing authenticity, enabling trust, and allowing reproducibility. So every resource/entity has one or more provenance resources. They also link to an agent. We are less interested in agents here. What we are interested in is the fact that provenance can provide a bridge. It can point to the normalized resource as its target, but then it can also contain one or more entity references. We can use the entity references to point to an original copy of the resource that shows the original data. Here's how it works. We make or generate a copy of the original resource as it comes in. Then we process the data and create the normalized resource. Then we link the two using the provenance resource. Now, it is important to note that the original resource is not semantically correct. In fact, it may not even be 100% structurally correct at the field level. This is just the nature of it being based on unclean data. However, it is structurally correct enough for other systems to work with. So how can another system work with this? Well, first off, if the other system doesn't care about original values for its particular use case, then it doesn't have to do anything. It just makes a normal FHIR query and gets back the expected response with no extra data. If the other system does want to know about original values, it just needs to use a standard rev include to get the provenance. Then it can retrieve the ID of the original resource from the provenance and make a second call to get that resource. So does this solve our problem? Well, is it consistent? Yes. I think I just demonstrated how a system could automatically retrieve the data. It certainly prevents complication and bloat. A system that doesn't need original values doesn't pay any price and is completely FHIR native. Finally, given that the access to the original resource is via ID only, and only when requested, we can easily move this data to any storage we want. It doesn't need to be co-located with the other resources or even well indexed, so it can be moved off to a cheaper solution like S3. If you'd like to read more about this, I do have a blog post out there on our website. Also, if you want to email me or reach out in the speaker gallery, I'd love to chat. If you want to know more about Diameter Health and what we do, you can certainly hit our website, or you can email us. We'd love to talk to you. In just a second, I would be happy to take your questions. But first, thank you for listening. I hope you're enjoying the conference, and I hope you have a wonderful day.
Thank you, Sam. Now would be an opportunity, if anyone had any questions, to post them in the Q&A or in the chat on Whova. Here we are. I had to actually hit refresh in order for the questions to come up. So give me a moment. The first question that I see on there is from Brian Wright. And he asks, based on other discussions this week, do your provenance records target specific versions of the resources?
So they certainly could. We at Diameter Health have not chosen to implement versioning at this point. We'll obviously create provenance and to show as resources change, but we've found that when working with medical data and the way that our customers want to work with it, implementing versioning is not what they need. But if we were to implement versioning, certainly we could point to a version.
The next question that's in the Q&A is from Brett Marquardt, who asks, when you say the provenance points to the original, is that a CDA entry or a transform to FHIR resource before enrichment?
So it'd be a FHIR resource that was created off of the CCD entry before any enrichment or anything else is done. So that's my point about it potentially not being either semantically or necessarily structurally correct, because we would bring in exactly originally what we saw in that entry, but we would create that as a FHIR resource. Also, when we start taking native FHIR, which I'm, think that is not too far off, we'll just create a copy of that original resource.
We have another question from Camilla Altman. Does this handle patient merges? And if so, how does that work with your framework?
It's a great question. So patient merges is one of those things where we work with each client to figure out exactly how they want to handle patient merges. It's obviously a complicated question. We work a lot with payers who have multiple different systems, and generally they want their system, the cost system that does their explanation of benefits and so on and so forth, to be the system of record for what is the patient demographic data. So we have the ability to say, okay, yeah, what comes in from that system, that's golden, we're not going to touch it. As they send in updates to that data, we will update that data, but we won't take data from clinical for those particular customers and overwrite that data. Hope that kind of answers your question.
The next question is from Kevin. Are there blockchain solutions to this problem?
Are there blockchain solutions? Well, I mean, I think there are always blockchain solutions to everything, because blockchain is one of those wonderful sort of buzzes that's out there. I think that, to the extent that you would want to freeze the data and say, I've written it to a blockchain and can guarantee you that I have never changed it. What I would ask is there a really good use to that ability to freeze the data? I'm sure there are some use cases where it would make sense. I haven't run into them. In my experience, this data is a little bit fluid, and you want to make sure that you can account for that fluidity. It's that fluidity, as we saw earlier at the keynote, the mistakes are made, and if we can't adjust those mistakes because we have some sort of rigid blockchain system, then there can be some problems there. Now, that said, I'm sure there are use cases where it would make sense, just not the ones we run into.
And what appears to be a follow-up to the earlier question about pointing to the original, do you maintain a reference in the FHIR resource back to the CDA document where it came from?
So yes, not necessarily within the resource itself. We will provide a link back to the through the provenance to the original ID of the document that it came in on, and you can also request that document as a document through a document reference for that patient. And and we can also outbound it as a binary reference for you.
Thank you everyone for your attention and for your questions. The questions will still be available in Whova after the session. So Sam, if you have an opportunity to take a look at any new ones that may come in, and the recording should be available in the next day or so. So thank you all, and enjoy your next sessions.
Thank you. Have a good day.